Good afternoon, everyone. My name is Bahan Amni, and I work for Crosspoint Labs. And today I will show you how I was able to break pretty much all antivirus and EDR solutions as a result of what I believe is incomplete documentation of certain APIs in Windows. So here is the quick session outline for what I will be covering today. So first, we'll have some background on links, and more specifically on registry symbolic links. And next, we'll have a look at Microsoft documentation and the pitfalls related to creating and opening registry symbolic links based on that documentation. And then we'll dive into a security vulnerability that I found during a research I did last year. And we'll also cover the security impact of that vulnerability, and I'll show a demo as well. And finally, we'll wrap up with some key takeaways and practical tips. So symbolic links, as you may already know, they can pose security risk if not handled properly, and they have been used in several attacks like privilege escalations and denial of service attacks. And the vulnerability I will be covering in today's session belongs to that class of vulnerabilities. Now here in this list, I have some known types of links in Windows. So for instance, we have the NTFS symbolic link. And for that type of links, you need to be either an admin or authorized by an admin to be able to create that type of links. If you try to delete a link of the type NTFS symbolic link using a Win32 API like the delete file, only the link will be deleted and not the target. And that behavior is similar to other links, link types in Windows. So it's similar to the directory junctions, to hard links, and so on. But the exception to that is the registry symbolic links at the bottom here. For those, you only need to be a standard user, so not admin, to be able to create that type of links, unless you are trying to create the link at a registry location that the standard user does not have right access to. But the interesting bit about those types of link is that if you try to delete the link using the common Win32 APIs like the reg delete key, the target will be deleted rather than the link. And I should mention that it's not only that API that will result in deleting the target, but there is no documented Win32 API that actually lets you delete a registry symbolic link. And as you can imagine, that has some security ramification that we will explore later in this presentation. Now, what are those registry symbolic links? So despite them being part of Windows for maybe 30 years, since the times of Windows NT, they seems to be less known than other types of links. And what they are just simply a feature in the Windows registry that enables you to create a link or link that redirect you from source key to a target key. Basically, you mirror the target key at the source location. And one example to that you may have interacted with is the current control set. And that basically typically redirects you to control set 001, which is the last control set that Windows was booted with. It could also redirect you to control set 002, which is the last good known control set that Windows was booted with. Okay. Now, if you try to view those symbolic links in the built-in regedit, they will appear just regular keys, and there will be no indication that those are symbolic links. But if you want to view the underlying structure of those, you would need to use other tools like the one I'm using here, Total Registry, which was written, I think, by Pavel Yosefich, who has written also a nice blog post on this topic. Now, the underlying structure of these links is very simple. It's an empty key, and it has one value with the name symbolic link name and with the type reg_link, and has a string value that contains or specify the absolute native registry path of the target key that you want to redirect to. That's pretty much what I want to think. Yeah. Now, I have a few slides that cover information on how to create and open registry symbolic links, but I won't go through in details, but I just want to highlight a few things, or one thing basically, which this documentation, especially the documentation around creating registry symbolic links, has several issues that ranges from some typos to ambiguous specification to even incorrect information. So if a software developer tries to create a registry symbolic link based on that documentation, they are likely to fail to do so. Now, creating registry symbolic link might be unnecessary for modern application, but they might be useful for the developers to create them in order to test the correctness of their application in case they are encountering a key that happens to be a symlink. So, for example, if they try to delete a link and that links happen to be a symlink, so it's good that they are able to test their application against those. But if there's no way for them to, or it's difficult to create those symlinks, it might be also difficult for them to test their application. Now, speaking of the delete register symlink, which is what I want to focus on in this presentation, and as I have mentioned already, it behaves unexpectedly in a way that the target key is deleted rather than the link, and here are the details on that. So typically, when you are trying to interact with registry symbolic links, you first, using an API functions, you first open the key, obtain a handle to that, and then you pass on that handle to other APIs that perform an action on the key. So in this case, if you try to open the key without specifying the option, rig option open link, and then you pass on that handle to other APIs, like the Win32 APIs that delete keys, then the target will be deleted rather than the link, which is not really ideal. Now, what's even more interesting, if you open the key with the option rig option open link, and then you pass on the handle to the Win32 APIs that I've just mentioned, rig delete key or rig delete tree, the target will also be deleted. So basically, that leaves user mode developers with no documented way to delete links in the user mode. There is one way, though, to delete registry symbolic link is by using the native API NT delete key. But the problem with this API is, first, it's undocumented, and secondly, you need to explicitly import that from NTDLL library. Okay? But even then, you'll have to remember to open the key with the option rig option open link. Otherwise, you will also risk deleting the target rather than the link. If you are operating in the kernel mode, you obviously would need to call the native APIs, NT or ZW delete key, and then also you need to ensure that you are opening the key with this option. Otherwise, you will also delete the target. Okay, so we'll have now a look at the documentation provided by Microsoft when it comes to deleting the different types of links in Windows. So for the NTFS symbolic link, they have clearly documented that, as part of the delete file API, where they have a subsection with the title symbolic link behavior. And there they stated that if the path points to a symbolic link, the symbolic link is deleted, not the target. So it's a very clear documentation. They tell you what API to use to delete the link and what is the behavior. So, and similarly, they have done that for other symbolic links where, for example, for the hard link, they tell you to use the function delete file. For directory junctions, they tell you to use the remove directory in order to delete the directory junction. And I guess you get the point here. So more or less, they have documented something about how to delete the link in Windows. But how does things look for registry in this case, for registry symbolic links? So for registry symbolic link, unfortunately, Microsoft does not provide any documentation for how to delete that type of links. And that is evident in the absence of any information in documentation like those APIs, rig delete key or rig delete tree, that has anything related to registry symbolic link. Typically, you would see that information under the remarks section, but you'll see here that there is nothing mentioned regarding that or regarding symbolic link in general. And should also point out that it's not only these documentation that lack information about registry symbolic link, but there's nowhere else in Microsoft documentation that covers that type of links. And that can be a concern because software developers might overlook the importance of handling registry symbolic links when they are referring to this documentation. Now we understand that deleting a registry link can result in deleting the target, but how does that become a vulnerability? So the vulnerability, as I'm phrasing it here, sorry, is what you see is not what you delete. And basically, it's a situation that creates a mismatch between what a programmer intends and what is actually deleted by Windows. And normally, this is not an issue because, and it's similar to other vulnerabilities related to symlink, which in a way you can fool or trick a privileged process into following the symlink, and then in this case, make it delete a protected registry. Normally, this is not an issue because either the privileged process would do the right thing, which is doing user impersonation before performing an action on unprotected registry key, or they simply don't delete a key in unprotected location, which basically avoids the problem altogether. However, there are certain types of application like the antivirus or EDR agents that their objective is to remediate or remove detected threats, including malicious registry keys or unwanted keys. Now, for them to be able to achieve that goal, lowering their high privilege, the system privilege to user will be safer, but might be insufficient to clear up the malicious key. So what they do, they go at the unwanted key with their high system privilege, and then they try to delete that to ensure that they are deleting that. But what happens is that they also expose themselves to potential security risk if the key that happens, the key they are trying to delete happens to be a symlink, and they fail to check that prior to deleting it. So that's basically the vulnerability here. Now, how widespread this issue is. So we and I say we as I and with the help of colleagues and friends, and big thanks to everyone who helped me with that, we tested 18 different vendors, and we found out that the 16 out of them failed to handle registry symbolic links. Okay? And since then, they all have patched their product, so they now are able to handle that case. But I should point out that we were unable to test all vendors, so it's crucial that all vendors take a note of what I'm presenting here and test their products to ensure that their product is not vulnerable to this issue. And I should also point out that even though my research was focused on AV and EDR, it's possible that other types of products are also vulnerable to this issue. When it comes to the CVEs, I think more than half have issued CVEs or security advisories. This column here might be not fully updated, but yeah, it's more or less half of them have issued CVEs for this vulnerability. Yes, now I would like to talk a little bit about the process I went through to identify the risk or the security risk of this vulnerability. So we know that standard users have write access to the current user registry hive, including the keys within that registry hive. At least that was my assumption, but I wanted to double check that. So I used a tool like Access Check from sysinternals to try to find out if there are registry keys that the standard user does not have write access to within that current user registry hive. And I found a couple of interesting ones. The first one is the second line here, which is the registry location that the browser edge stores a path to a manifest file, and inside that manifest file, there is a path to the native messaging host executable, which is an executable that facilitates the communication between the extensions that runs within the browser edge and the host system. And it is possible using this vulnerability to man in the middle that executable. But I won't be covering this in this session. I'm happy to discuss this offline. The second interesting registry key that the standard user does not have write access to is this one, which is current user software policies. I will get into that in a bit, but I just want to point out a couple of things. First, Windows does not allow you to create registry symlink between the different registry hives. So you cannot create one from current user to the local machine registry hive for security reasons. And the second thing, I also did a similar test where I ran access check on the local machine registry hive to try to find out if there are registry keys that the standard user does have write access to. And I found a bunch of those, but none were interesting in the context of AV and EDR, meaning even if I was able to create a symlink under those locations, it would have been difficult for me to trigger the AV or the EDR to delete those locations, including the symlinks. I also didn't spend too much investigating whether that is actually possible or not. Now back to the current user software policy key that I mentioned before. That location is where the local group policies are stored in Windows for the currently logged in user. Okay, and in Windows, only admin accounts are authorized to configure group policies. Standard users are not allowed to do so. And if you happen to have a corporate Windows laptop, you probably are assigned the standard account. And if you try to configure group policies by running, for example, gpedit.msc, you will get an access is denied error, as expected. Now, there are some interesting policies that you can set within the EC group policies. One example to that is the always install elevated. And what does that policy does is that basically instruct Windows to install MSI installer or Windows install packages using the system or the elevated system privileges, even in a standard account. But Windows requires this policy to be set per machine and per user for it to be in effect. And we'll come back to this policy later on. But you just need to remember that basically this policy elevates your system, elevate your code or MSI installation to system. So you can, for example, install it in a system-wide installation. Another interesting one is the process mitigation option, which basically enables you to disable security mitigation on the system. And those were just two examples for two policies out of thousands you can set in Windows from Microsoft and other vendors. So it is imperative on Windows to secure that location, that policies keys, because otherwise the attackers could exploit that to set policies and gain additional capabilities or permissions or access on the system. Now, putting those two together, the policies keys that I talked about and the vulnerability that I covered previously, if we put those together, here is an example for an attack vector that attackers could leverage in order for them to configure group policies if they are running within a standard account. And the attack goes like this. Oh, sorry. The attacker would first create a symlink in a location, in a registry location, where they know that the privilege process would be deleting. And then they will either wait for that privilege process or trigger it for it to delete that location, including the symlink. And the symlink would be pointing to the current user software policies, which by default is a read-only policy, registry key. Now, the privilege process would be thinking that it's deleting that symlink key, but in reality, it will be deleting what it is pointing to, which is the policies key. And at this point, once this policy has been deleted, the attacker can recreate the policies key, but this time with write permission. And once they have done that, they can set whatever policies they want as part of the group policies, including the always install elevated. So if that always install elevated was already set per machine, they can, by leveraging this vulnerability, set it per user, and this way they can leverage their code from standard user to system by running it as an MSI installer. Now I have a demo that illustrates that attack vector. I hope it's gonna work here. I'm not sure if it's possible to see that in the back, but I will try to use the magnifier at least. Yeah, I hope this is visible from the back. But I have a standard user named limited running with the, with the medium integrity level. And I'm running my tool just in a second. I'll try to pause it a few times just so you are able to see using the magnifier. So the first thing that my tool does is it runs an MSI installer just to verify that it's running as a standard user without the elevated system privileges, as you would expect on a default installation. And this MSI installer, all it does is it just execute cmd.exe. Sorry about that. So the MSI is going to run. It runs cmd.exe. If we run whoami, we'll see it's running as limited, what you would expect in a default standard user. And then it runs a bunch of verifications on the system. These verifications include just to check that the policies keys is read-only, as you would expect on a default behavior, on a default standard user, and also tries to delete or write to that policies keys, but it will get access denied error as expected. Just before I go into that step. And the second step would be creating basically the exploit, which is creating a key that looks like a malicious key to the AV I'm targeting now. And inside that, I'll be creating a symlink that points to the policies keys. And once I have done that, I will trigger the AV. In this case, I'm running run quick scan, basically triggering the AV. I'm running the quick scan. I'm just minimizing it here. By the way, these blue rectangles are just for me to hide the identity of this AV, because I just thought it wasn't fair to pick up on one when there are many that are vulnerable. So the quick scan is running in the background, and what it does, it's scanning the registry, and it has a list of bad known registry keys as part of its definitions, and if it finds the one I created, it will just automatically try to delete it, including the symlink I created. And it will fail to do so. It will try to follow the symlink and will end up deleting the policies. So it's running here, as you see, and soon it will delete the policies keys as a result of it trying to delete the symlink. There you go. Here it was, the policies was deleted, and at this point I created the policies with write permissions, and then I was able also to add the always install elevated, the one I talked about. And once I have done that, I will rerun the MSI installer, and the MSI installer would run CMD. And here we can see that we got system this time from a standard account. So that was the first attack vector. The second attack vector, which is more specific to AV and EDR, typically because those type of application, they implement anti-tamper protection, which is a technique for them to prevent attackers from fiddling or deleting registry objects that belongs to the AV or the EDR, including registry keys. So in this attack vector, what the attacker can do is they create a symlink, but this time under the local machine registry hive, and then they make that symlink point to the AV system service, which is the system service key, which is the key that describes to Windows how to run the AV service during boot time. And then in the second step, they will trigger the AV or the EDR. For example, they can run quick scan, as I did in the demo. And once the AV detects that symlink, because I'm creating it as part of a malicious key or something that looks like malicious key for the AV will try to delete it, but it will end up following that and deleting its own registry key. And that will succeed because the anti-tamper protection is not enforced on the AV process itself. And once this has been deleted, on the second, once you rebooted the system, Windows will not have information on how to run the AV service, which means you are able to disable the AV or the EDR on the system that way. And this is an example for an EDR agent that was disabled this way. So the EDR deleted its own service registry key, and when I rebooted the system, the UI of the EDR agent popped up and told me that the endpoint security agent is not running because the core service of the EDR was no longer running on the system. Now, just to recap very quickly for the security impact of this vulnerability is that attackers running as a standard in the standard user account, they can configure group policies that would otherwise be inaccessible to them. And that means also that they can gain capabilities on the system depending on what policies they are able to set. And as an extension to that first point, they can perform local privilege escalation on the system and run their code as system from a standard account. And finally, they can disable the AV or the EDR that runs on the system. Oh, sorry. Now, on the conclusion part, and just to round up this presentation, and let's have a look at the tip of the iceberg bug that I've just talked about, and see how did this bug surface and who is it to blame really in this bug. Now, it is tempting to blame the software vendor, especially if that software vendor happens to be an antivirus company. But to be fair, if you examine the underlying causes of this issue, you will see a number of unfortunate factors that led to pretty much all the AV and EDR industry making the same mistake. And that starts with, at the bottom here, where we have unexpected behavior in a way that registry link or the target key when you are trying to delete a link was deleted rather than the link. And secondly, we have an inadequate documentation that first failed to document that unexpected behavior. And secondly, it also failed to warn about the security risks of deleting registry links in Windows. And I guess finally, some responsibility must be also placed on the software vendors for not having tested their products against deleting the different registry objects, including registry links. Now, I tried to reach out to Microsoft, but I couldn't get them to update the documentation to document the likely to be overlooked risk of deleting registry links, or at least document that unexpected behavior I talked about, which is if you are trying to delete a link, as a result, you end up deleting the target rather than the source or the link. But I hope after this presentation, somebody at Microsoft will listen and update that documentation. The second thing I would call on Microsoft to do is make it, maybe consider changing the default behavior so the target key is not deleted when you try to delete the link. And finally, make it difficult to delete the current user software policies keys, even for admin or system accounts. And they have done so already for the equivalent policies keys that is part of the local machine hive. And there you will find a sub key with the name prevent policy key delete. And what they have done is basically they removed the delete permission for all accounts except for the trusted installer account for that particular subkey, which means if you try to delete it, you will fail as a system, and that also means you will also fail to delete the policies key. I just want to mention that you don't really need to wait for Microsoft to do this. You can also do it yourself, and this is also what I will mention on this slide. So here are some practical tips for what you can do for the defenders out there. So if you have an EDR solution, or if maybe you are running sysmon on your endpoint, you can create a rule that check if the current user software policies get deleted. And if so, investigate why this was deleted. Secondly, you can remove the delete permission for all accounts except for the trusted installer. That makes it difficult to delete that policies keys that I was talking about, even for the admin or system accounts. And you can remove that either on the policies itself or create a subkey under that and then remove that delete permissions from that subkey. But that would require some testing. I personally haven't tested that yet, but this is just a suggestion for something you can do. And also, it's needless to say that always install elevated policies should never be used. You have other tools to install MSI installer remotely, so that shouldn't be necessary to set. And it's always good to maintain an overview of offline AVR or EDR agent on active endpoints. For the software vendors out there, it's good to review your code to ensure it does not allow deleting or writing to privileged registry keys via registry symlink manipulation. So always, if you are trying to delete a registry symlink, you have to check is that or if your code is trying to delete a registry key, you need to check if that is a symlink or not, and if so, you need to do the proper coding around it. It's always a good practice to use user impersonation when accessing or performing an action on unprotected registry keys or objects, for that matter, from privileged processes, which means if you're running as system, lower your privileges to the currently logged in user before you are performing an action on unprotected registry keys. And finally, you should always set the correct access control list on your created registry keys. And finally, some key takeaways for this presentation. So like other types of links in Windows, registry symbolic links can pose potential security risk if not handled properly. And that basically underscores the importance of exercising caution when you are performing an action on registry symbolic link. I guess the main key takeaway for my presentation is that ideally, if you are a software vendor, you should fully document your API behavior. And if for some reason that is not possible, at least document the potential security risk if you are aware of any, in order to promote secure coding practices and reduce the likelihood of security incidents. Simply because software developers are not always aware of the intricate details of your API behaviors and what could happen as a result of maybe not using it properly. I guess that was all from me. So thank you everyone for listening. Yes, I guess I have some more minutes if there are any questions.
Yeah, great talk. So you described two types of attacks. One was a little bit more generic, and the other one was kind of specific to the security vendors, where they were deleting their own registry keys.
Yeah.
All the 16 failures you noticed, was it all kind of that latter style, where they were deleting their own registry key?
So yeah, I should mention that when we tested those 16 vendors, we tested mainly the remediation component of those products. So we basically created a key that looks like a malicious key to those vendors, and then we saw if it was following the symlinks and deleting what we were pointing that symlink to, including it could possibly point to its own registry keys. And I know for certain AV and EDR solutions, they have some code that deletes a registry key during boot time for operation purposes or maintenance purposes. And for those specific ones, it's even easier to attack, to target those, because all you have to do as an attacker is just to create a symlink at those locations, and during boot, the AV or the ADR would delete whatever it is pointing to, including registry that belongs to the AV itself.
Thank you very much for sharing this interesting research. You mentioned that there are 2 vendors who did it actually right, who were not vulnerable. Do you have actually ideas on why they did it right?
They basically used the correct, so they either, I didn't check that, but they either did not, so they would check that if the key is a symlink or not, and if so, they might just not delete it at all. Or they would be using the NT-delete key, which is the native API that I mentioned before. But as I mentioned, the problem with that API is it's undocumented, and you have to explicitly import that from NT-DLL key. And I assume when these products have patched their products, they ended up using that native API. Yeah. Right. Thank you, everyone, for listening.